Okay, so this is the third do know from week 2, which we're going to start going over right now, starting with question 16. Question 16 says, the theory that light was not the primary stimulus affecting the direction of bacterial migration is. So we want to know if light is the reason that the bacteria went the way they went. So if we look at table 1, or study 1, all of these trials went north. The results, so most of them went north. Now if we look here, we can still see that most of them are going north. If you read the passage here, it says north was moved 90 degrees clockwise, so 90 degrees, 90 degrees, 90 degrees. So we want to know why they were always going north. So let's look back here. Trial 1 was conducted under standard laboratory conditions. That means this is our control. Trial 2, the microscope was shielded from all external light. So trial 2 was dark. So control, dark. Trial 3 and 4, it was rotated clockwise. So these were rotations. And then trial 5, the microscope was moved. So that was location. So in normal light and in the dark, these both still went north. And no matter what, they went north. So light was not the primary stimulus if you compare trial 1 and 2 of study 1, because in light and in dark, they still both went north. All right. If the south pole of the magnet used in study 2 had been placed near the microscope slide, what would the most likely result have been? And here we had the north pole position near the microscope slide. So if it was the south pole instead of the north pole, that means the north pole was this way, we would see a shift of 180 degrees because this is an angle of 180 degrees. So our answer to number 17 is C. It's G here. Those are really bad highlights, I'm sorry. Number 18. It has been suggested that magnetic sensitivity helps magnetotactic bacteria orient themselves downwards. Such an orientation would be advantageous from an evolutionary standpoint if organisms that consume were mostly bottom, so we would not want them going down if they were going to be eaten when they went down, so it's not F. The bacteria could only reproduce by migrating upwards. They would only survive if they went up, definitely not G. Bacteria that stayed in the top layers of water tended to be dispersed. That just means they spread out. That doesn't really give us a huge advantage. And so that leaves us with J. The nutrients necessary for bacteria's survival were more abundant in the bottom. So if we wanted them to orient themselves toward the bottom to get their food, then that would make sense from an evolutionary perspective. All right, number 19. Researchers could gain the most useful information about the relationship between magnetic field strength and bacterial migration by repeating study 2 with. So study 2, they rotated where the North Pole was to see where they went. But now we want to know about strength and migration. We don't actually even have to look at the results here. We just want to look at the one that talks about strength of the magnets. And the only one that talks about strength of the magnets is C. So if you match more and less powerful magnets to magnetic field strength, that's what gives you that answer. Number 20, which of the following statements is supported by the results of study 1? I'm not going to flip back, but if you did flip back, you would see that all of them went north regardless of the position. So if we read the first answer choice, the majority of magnetotactic bacteria migrate towards the Earth's north pole. That's just looking at the table. Specifically, looking at this column, what do you see here? North, 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 north. North. I think it's 6 times. All right, and then what's the control in study 1? We already went over this sort of on accident. Trial 1 is the control because that one is the one that said standard laboratory conditions. Normally when you see something that says standard, that means control.